Right on this starter, and we're going to go through stuff very, very quickly. On this starter, if I'm looking at this, and I know that this angle is 3x plus 4, and they're marked so that these two angles are the same as each other, they have the same markings in them, then that means this angle here has to be 3x plus 4. So I can write 3x plus 4 in for this angle. We know this whole angle, the whole thing, is 7x minus 3. Well, the equation I can do is just using the angle addition postulate. This angle plus this angle should equal the whole thing. So 3x plus 4 plus 3x plus 4 should equal the whole thing, which was 7x minus 3. We collect like terms, you get 6x. Got other like terms here, the 4 and the 4, so plus 8 equals 7x minus 3. Subtract 6x on both sides. You end up with 8 equals x minus 3. Add 3 to both sides. You end up with x equals 11. They ask us to find the measure of all three angles. All you're going to do with that is take it and plug it in. If I plug in right here, 3 times 11 plus 4, 3 times 11 is 33, plus 4 is 37. So one of the angles is 37 degrees. Well, if this angle up here is 37 degrees, then this angle has to be 37 degrees because they were congruent. If these two are both 37, we know that together they add up to be the whole thing. I really don't even have to plug in over there. All I got to do is add those two together, and I get 74 degrees. So those are our three answers. All right, on the homework. Problem number 25. Problem number 25 on page 44. Problem 25, they give us, sorry, I have to get my book and be able to read it. Problem 25, they tell us that this angle is 2x plus 23. 23. And they tell us that the other angle they tell us this angle is 2x plus 23, and the other angle in 25 is 9x minus 5. This angle is 9x minus 5. As long as you can understand, you can write stuff this way, and as long as it makes sense to you. And they told us that the measure of angle ABC was 95. So ABC, which this is A, B, C, so this whole angle, this whole thing is 95 degrees. Well, then to set up an equation, all we're going to do is say this angle plus this angle should equal the whole thing. So 2x plus 23 plus 9x minus 5, this one plus this one should equal 95. I want to do a lot of this together. Just real quick, 9x and 11, or 2x give us 11x. We got 23 and a negative 5, that gives us 18. That equals 95. Subtract 18 on both sides. That gives us 77. I hope that's right. Equals, I think I'm right. Equals, I'm going to move the 11x over the other side because my pen didn't quite right. Then you divide by 11, you get x equals 7. They ask us to find the two angles. They said find the measure of angle ABD. measure of angle ABD. Well, angle ABD, D should be right here, is right there, is this angle. So we're just going to plug that in. 7, plug in for right here, so you get 2 times 7 plus 23, that's 14 plus 23. 14 plus 23 is 37, so that angle's 37 degrees. Then they tell us to find the measure of angle DBC. DBC is this angle. And what we could do is just take 95 minus 37, or we could plug in the 7 right here and put 9 times 7 minus 5. 9 times 7 is 63. 63 minus 5 is 58. Those two better add up to be 95 together, which I think they did. 26. 26, they tell us this is X. That's W. This is Y. And this out here I'm guessing is Z. And this angle is 6x plus 44. This angle right here is 6x plus 44. And this angle is negative 10x. Negative 10x plus 65. And they tell us that the whole angle this time is 117. So all the way around here is 117 degrees. The equation we're going to set up is this plus this equals the whole thing. And I'm just going to collect some like terms here together before I write anything down. 6x and negative 10x give you negative 4x. 44 and 65 give us 109, so plus 109. And that should equal 117. Subtract 109 on both sides. End up with negative 4x equals 8. Divide by negative 4. Divide both those by negative 4. 8 divided by negative 4, x equals negative 2. They want you to find the measure of angle XYW. Measure angle XYW. XYW is this angle. So we're going to take that negative 2 and we're going to plug it in right here. So 6 times negative 2 plus 44. 6 times negative 2 is negative 12 plus 44 is 32. That angle is 32 degrees. Then they want us to find the measure of angle WYZ. WYZ is this angle. We can just plug in negative 2 right there. Negative 10 times negative 2 plus 65. Negative 10 times negative 2 is positive 20. 20 plus 65 is 85. So that angle is 85. Again, if we add those two up, we should come up with 117. Problem 27. Problem 27, they tell us this is L, M, N, P, and this angle is negative 16x plus 13, negative 16x plus 13, and then the other angle is negative 20x plus 23, negative 20x plus 23. Well, we know that angle LMN here is a straight angle, so it's 180 degrees. So this angle plus this angle should add up to be 180. Again, I'm going to go ahead and collect my like terms when I put these together. That gives me a negative 36 x's. 13 and 23 give me 36, and we know that that should equal 180. Subtract 36 on both sides, subtract 36 on both. Those cancel, you're left with negative 36x equals 140. 44. Divide both sides by negative 36. And you end up with x equals a negative, let's get rid of that, x equals a negative 4. That's what x is. Probably didn't ask us to find x again. They asked us to find the measure of angle LMP. The measure of angle LMP. What LMP is this angle right here. So we're just going to take that negative 4 and we're going to stick it in there. Negative 16 times negative 4 plus 13. Negative 16 times negative 4 is positive 64. 64 plus 13 is 77. So that angle is 77. Now they also ask us to find the measure of angle NMP. That's this angle. And I'm going to do it a different way. Measure of angle NMP. Instead of plugging in here and doing all that math, if I know this angle over here is 77 degrees, all I got to do to find the rest of this angle over here is subtract it from 180. So 180 minus 77, borrow, gives us 301, so the other angle is 103 degrees. Problem 28. Problem 28, they tell us this angle is 14x plus 70. They tell us that the other angle is 20x plus 8. And we know that this is a straight angle. Notice I didn't even put the points on there or anything because we're doing the same thing again. They want to know ABX and CBX, which is these two angles. So we're just going to do the same thing that we've been doing. Collect like terms, 14x and 20x give me 34x. 70 and 8 give me 78. I know that these two together should add up to be 180. Subtract 78 on both sides. End up with 34x equals 102. Divide by 34. And you end up with x equals 34 will go in there, what, 3 times? So x equals 3. Once you know x is 3, you're just going to plug it back into one of these. I'm actually going to plug back into this one over here because it's easier. 20 times 3 plus 8. 20 times 3 is 60, 60 plus 8. So that angle is 68 degrees. That's one of your answers. Well, if that angle is 68 degrees, this one's got to be 180 minus 68. We borrow here, make that a 7. That's 8. 118. That angle is 118 degrees. Those are your two answers. $29. They tell me this angle is 15x minus 43. And the other angle is 8x plus 18. This little symbol down here tells us that it's a right angle. So these two added together should add up to equal the whole thing, which is 90 degrees. If I collect like terms here, I get 23x. Putting the 15 and the 8 together. Like terms here, negative 43, a positive 18 gives me, oops, not a positive, gives me a negative 25. All that should add up, these two together should add up to equal 90. Add 25 to both sides. You get 23x equals 115. Divide by 23. Those cancel out. Let's see, 5 times 23 is 115, so x equals 5. They wanted us to find angle RSQ and angle QST. RSQ is this angle. QST is this angle. I'm going to do this angle because it looks easier. 8 times 5 plus 18. 8 times 5 is 40 plus 18 is 58. So that angle is 58 degrees. I knew the two of them together add up to 90, so now I just take 90 minus 58. Borrow here, make that an 8. That's 2, 32. So this other angle over here is 32 degrees. That's your other answer. Problem 30. I'm not even going to write this stuff down on problem 30. They tell us this is a right angle. We look at the picture there. We collect like terms. You got 13x and 10x. So that's going to give you a total of 23x plus 21. That's this angle plus this angle. Well, those two angles added together should equal the whole thing, which is 90. Subtract 21 on both sides. These cancel out. You're left with 23x equals, borrow there. That makes that 9. It's that an 8. 8 minus 2 is 6, 69. Divide by 23. And x equals 3. We take that and we plug back in. This angle right here was 13x. So I'm just going to plug in to right there. 13 times 3 is 39. So this angle is 39 degrees. We knew that the whole thing was 90. So you take 90 minus 39. Borrow. That's 1, 5. So this angle up here is 51 degrees. All right, on the notes today, write this down, special pairs of angles. So pairs means two. So you're saying these two angles are special to each other for whatever reason. Special pairs of angles we're going to talk about, complementary angles, supplementary angles, vertical angles, linear pairs, and there's actually one more, which is adjacent angles. And after today, you'll probably never see me write out the word angles again. Use the symbols. So that's what we're going to cover, those special pairs of angles. All these are special to each other for whatever reason. Some of you might know complementary angles. Complementary angles, I think that's the first one we're going to go over. It's two angles that together add up to be a right angle or add up to be 90 degrees. You dealt with a few of those on the last assignment. I guess the first one we're going to talk about is adjacent angles, the one that I forgot up there. Adjacent angles. Adjacent angles are angles that share a common vertex and a common side. So adjacent angles, if we're looking with, you got two lines that intersect each other here. You got this line, you got this line. Together they form four angles. The adjacent angles, well, they all share a common vertex, but they also got to share a side. So if I look at this side of the angle right here, then the ones that are adjacent to each other are angle 1 and angle 4. Another pair of adjacent angles would be, if I look at angle 4 and angle 3. What I like to think of when I think of adjacent angles are neighbors. They're the ones that are right next door to each other. Another pair of adjacent angles would be angle 2 and angle 3. Another pair of adjacent angles would be angle 1 and angle 2. Oops, forgot my angle symbol. Notice 2 and 4 are not adjacent angles. They share a common vertex, but those are the sides for angle 4. Those are the sides for angle 2. They don't share a side. So those are adjacent angles. We don't do a whole lot with adjacent angles. You just have to know what they are because we use the terminology. Next. Complementary angles. If angles are complementary, then angle 1 and angle 2 are complementary. Well, what we mean by complementary is it's two angles whose sum or that add up to 90 degrees. So if I look here, we did a bunch of problems like this on the assignment last night. If I do this, if I look at these two have to add up to be that which is 90 degrees, a right angle. So they are said to be complementary to each other. Now these two angles are also adjacent to each other because they share a vertex and they share this side. But the thing we care about more is that angle 1 plus angle, and I should write this a different way, measure of angle 1 plus the measure of angle 2 is going to equal 90 degrees. It's going to equal 90. And we did that. So on some of the problems last night, they told you maybe this angle was 2x plus 5. This angle was 7x minus 3. Well, you took that plus that, and you set it equal to 90. Because you knew the two of them together had to add up to be 90. And that's what complementary means. Some of the problems will just say find the complement. If they ask you to find the complement of an angle like a 40-degree angle, they say find the complement of a 40-degree angle. Then all you do is take that and subtract it from 90. So the complement of a 40-degree angle is a 50-degree angle. Those two are complements of each other. That's complementary angles. The next one, supplementary angles. Instead of two angles adding up to 90 like on this page, supplementary angles are two angles that add up to 180. We use supplementary a little more than we use complementary. So supplementary angles, two angles, just two, not three, not four, just two angles that add up to 180. All right, adjacent angles formed by two intersecting lines are supplementary and are also called a linear pair. We're going to talk about that here in a second. But if I look at this, I know that line L right there, L1, is a straight angle. Well, if it's a straight angle, then this angle and this angle have to add up to be 180. So angle 1, the measure of angle 1, plus the measure of angle 4 has to equal 180. Well, if that's the case, then angle 1 and angle 4 are supplementary angles. So 1 and 4 are supplementary. Down here I say angle 1 and angle 2. If I look at angle 1 and angle 2 here, again they form a straight angle together. So they're supplementary angles. They're supplementary to each other. That means that the two of them together have to add up to 180. Angle 2 and angle 3 are supplementary to each other. Angle 3 and angle 4 are supplementary to each other. And that's sort of what leads to this next thing, a linear pair. A linear pair is just a pair of angles that together make a line. So if I draw a picture out here and I have this line, and I draw another ray here, this is angle 6 and this is angle 7, we can say angle 6 and angle 7 are a linear pair. Anytime you have a linear pair is always going to have is always going to be supplementary angles. So if two angles are a linear pair, they're also supplementary. Now just because two angles are supplementary doesn't mean they're a linear pair. Because I could have this. I could tell you that this angle right here is 50 degrees. Then I could have another angle that looks like this. And I tell you that that angle is 130 degrees. Well, those two together add up to 180. So they're supplementary to each other. But they don't form a line together, so they're not a linear pair. So all linear pairs are supplementary angles, but not all supplementary angles are linear pairs. Vertical angles. This one's pretty important too. Got to be able to pick vertical angles out in the picture. Vertical angles are sort of the opposite of adjacent angles. If we're looking at this picture, we said angle 1 and angle 4 were adjacent angles. They're also supplementary angles. They're also a linear pair. But when we draw two lines, the pairs of non-adjacent angles, non-adjacent means the ones that aren't neighbors to each other, aren't right next to each other. So these are adjacent to each other. We don't want those. 1 and 2 are adjacent to each other, but 1 is not adjacent with 3. Those are the non-adjacent ones, angle 1 and angle 3. So here we would say angle 1 and angle 3 are vertical angles. The other pair of vertical angles you should be able to pick out, angle 2 and angle 4 are vertical angles. Now the good thing about vertical angles, if I go in here and I put a number in here, I put in, let's say, angle 3 right here, we'll say it's 80 degrees. Well, I can look at angle 2 over here, and I know that angle 2 has to be a linear pair with angle 3, and they have to be supplementary to each other. Well, if those two are supplementary, that means they got to add up to 180. If this is 80, then this one over here has to be 100. That one's 100 degrees, and this one's 80 degrees. And I look over here at 1 and 2, they're a linear pair. So angle 1 and angle 2 have to add up to 180, so that means angle 1 has to be 80 degrees. Angle 1 and angle 4 are a linear pair, they're supplementary to each other. So if angle 1 is 80, angle 4 has to be 100 degrees. Then what do you notice about angle 2 and angle 4? And this is going to work every single time. Angle 2 and angle 4 right here, oh, they have the same measurement. Well, that means they're congruent. So we can say angle 2 is congruent to angle 4. We can also say that angle 1 is congruent to angle 3. And the reason that those angles are congruent to each other, I should say angle there, is because they are vertical angles. Vertical angles, and that's what's on the next slide, I think. What's special about those vertical angles? They have to have the same measure. Our first theorem that we're going to cover is this theorem right here. Vertical angles are congruent. You won't ever see me write out like that again, and when we use it from here on out, this is what you're going to write. Vertical, just shorten that up. Just abbreviate it. Vertical angles are congruent. Gotta know that theorem. Vertical angles are congruent. So anytime you draw two lines and they cross each other, without knowing any other information other than those are lines, I know that this angle and this angle have to be the same. They have to be congruent to each other. This angle and this angle have to be congruent to each other. Vertical angles must be congruent. All right, the assignment's on page 52, and we're going to do as much of this assignment together as we can. So get your books out, get out a clean sheet of paper, and we'll start working out problems. 1 through 26, 28, 31 through 43, 45 through 49, 51 through 59. This one, I will agree, is sort of a long assignment, but we're going to try to do a bunch of it together. Number 1. Or I'm sorry, what did I do? Let's go back to the previous. Number 1. Number 1 on page 52 says, explain what is different between adjacent angles and vertical angles. Adjacent angles share a side. So that angle, those two angles would be adjacent. Vertical angles, can't do that. Vertical angles are the angles that are across from each other. So adjacent angles share a side. Vertical angles don't share a side. That angle and that angle don't share a side. Those are vertical. So that's the difference. Adjacent share a side, vertical don't. Which one doesn't belong on the next one? And explain your reasoning. If I look through there, the first one's got angle 1 and angle 2, then you know it's a right angle. That means they're complementary. 40 and 50 add up to 90, so they're complementary. Angle 3 and angle 4 in the next picture are supplementary. 25 plus 65 add up to 90, so they're complementary. So the one that doesn't belong is the one that looks like this. With angle 3 and angle 4. That one doesn't belong because they are supplementary to each other, and all the rest of them were complementary to each other. Number three. Number three says name a pair, and all these say name a pair of these angles. So name a pair of complementary adjacent angles. That means they got to share a side because they're adjacent, and they got to add up to 90. So I look over here, these two share a side, but they don't add up to 90. These two, 56 plus 34, well 56 plus 34 is 90. So these two angles, this one and this one, are adjacent and they're complementary. So we're going to name those angle LMJ and angle MJ. No, hold on, I named that wrong. Jeez, that's horrible. Angle LJM and angle MJN. That's what happens when you get in a hurry. Now we want adjacent and supplementary. So they share a side and they add up to 180. Well, if I look at this picture, we don't even have 180 degrees in that picture, so that's not going to work. We look at this one, we got a straight angle right there. Angle KJN is a straight angle. Well, there's several different ones we could name here. Probably the easiest ones. Angle LJK and angle LJN. Now you could have also named this angle KJM and then angle MJN, because together they form a straight angle. Non-adjacent complementary angles. So we want two angles that aren't neighbors, aren't hooked together, but still add up to 90. Well, I just look for two numbers that add up to 90 degrees. 124 and 56, that's not going to add up to 90. 56 and 34 add up to 90, but they're adjacent to each other. And we want non-adjacent angles that aren't hooked together. If I look at this, 49 plus 41, that adds up to 90. So we can say angle EGF and angle PJN. Non-adjacent supplementary angles. So now we want two angles that aren't hooked together that add up to 180. Two angles that aren't hooked together. So I look for two numbers that add up to 180 in the picture. And I'm just going to tell you it's 56 and 124. So angle, the 124 degree angle is angle FGH. And it's supplementary to angle LJM. Don't let stuff like non-adjacent confuse you. It just means they're not hooked together. Adjacent means they share a side. Non-adjacent means they don't share a side. Next one, number 7. Angle 1 is complementary to angle 2, and angle 1 is 23 degrees. So measure of angle 1. Measure of angle 1 is 23 degrees. And we want to find the measure of angle 2. And we know that they are complementary to each other. Well, if they're complementary, that means they add up to 90. So all we got to do is take 90 minus 23, borrow here. It gives us 7. 8 minus 2 is 6. So angle 2 has got to be 67 degrees. Number 8 says angle 3 is complementary to angle 4, and angle 3 is 46 degrees. So if angle 3 is 46 degrees and we want to find the measure of angle 4, well, we just take 90 because they're complementary. 90 minus 46, we subtract that, borrow, we get 4 there, so angle 4 has got to be 44 degrees. Number 9. Angle 5 is supplementary to angle 6, and angle 5 is 78. So supplementary means they got to add up to 180. So I'm just going to take 180 minus 78. That gives you 102 degrees. And I'm not even going to write out the angle this time. So your angle, which angle were we looking for that time? Angle 6. Angle 6 is 102 degrees. Angle 7 is supplementary to angle 8. Angle 7 is 109 degrees. So we just take 180 minus 109. You end up with 71. So the other angle is 71 degrees. Don't make those harder than they are. If they're complementary, they got to add up to 90. If they're supplementary, they got to add up to 180. So when they say the complement of something, you know that they got to add up to 90. The supplement of something, they got to add up to 180. Number 11. On number 11, we look at this. We know that these two angles are supplementary to each other. Just says find the measure of each angle. So we're going to find the measure of each one of these angles. All we're going to do is set up an equation. If these are supplementary, then this plus this has to equal 180. So 3x plus 5 plus 10x minus 7 has to equal 180. Collect like terms. 3x and 10x give us 13x. A 5 and a negative 7 give us minus 2 equals 180. Add 2 to both sides. You get 13x equals 182. Divide both sides by 13. I have my calculator with me, so 13 will go into 18 once. With 5 left over, 13 will go into 52 4 times, so x equals 14. We want to find each one of these angles. Instead of naming it like angle QRT and putting down the measure, I'm just going to put the numbers down here. We take 14 and I'm going to plug it right into here. 10 times 14 minus 7. 10 times 14 is 140. 140 minus 7 is 133 degrees. So that's one of our angles. To find the other one, instead of plugging in 14, because off the top of my head I can't think what 3 times 14 is, I'm just going to take that 133 and subtract it from 180. And I get 47. So this angle over here has to be 47 degrees. So those are your two answers there. Number 12. Instead of being supplementary, we know that these two angles are complementary. So I'm just going to take these two angles and add them together to equal 90. So 15x minus 2 plus 7x plus 4 equals 90. Collect like terms. 22x minus 2, a minus 2 and a positive 4 give you plus 2 equals 90. Subtract 2 on both sides. You get 22x equals 88. Divide by 22. You end up with x equals 4. And that's not your answer. You got to plug that in. I'm going to plug into this one right here because I know what 7 times 4 is. 7 times 4 is 28. 28 plus 4 is 32. So this angle, 32 degrees. Subtract that from 90. 90 minus 32. Use your calculator if you need to. That gives you 58 degrees. So this angle right here is 58 degrees. Those are your two answers for 11 and 12. Angle angle UVW and angle XYZ are complementary angles. Measure of angle UVW is x minus 10. Measure of angle XYZ is 4x minus 10. And they want us to find each angle, I think. Let's see, 13, make sure. 13, yeah, it's still finding the measure of each angle. Should have looked right here. Find the measure of each angle. So we're just going to find those. I don't even have to draw a picture for this. I could. We know that they're complementary, so that tells me they add up to 90. If that helps you, circle complementary and write down 90. Down here, circle supplementary and write down 180. You know that they add up to that. All you're going to do is take this angle, add them together, set it equal to 90. So x minus 10 plus 4x minus 10 equals 90. Collect like terms. That gives you 5x. A negative 10 and a negative 10 give you minus 20 equals 90. Add 20 to both sides. You get 5x equals 110. Divide both sides by 5. X equals, 5 will go into 11 twice. With 1 left over, 5 will go into 10 twice. So x equals 22. Well, that's not our answer. We need to plug that back in. Plug it in right here. You just get 22 minus 10. 22 minus 10 is 12 degrees. That's one of our answers. Plug it in over here. You get 4 times 22 minus 10. 4 times 22 is 88. 88 minus 10 is 78. Some of you are probably saying, why'd you plug that in? Why didn't you just subtract 90 minus 12? You could have done that also, and you should have got the same answer. So 12 and 78. Next one, we know that they're supplementary. So 3x minus 17 plus the other angle, 1/2 x, stupid thing, minus 5 should equal 180. Maybe the easiest thing to do here, you could multiply this whole equation by 2 to get rid of the fraction, but since it's just 1/2, I would probably just leave it that way or change it to a decimal, 0.5. Now, if your fraction is 1/3 or 1/5 or 1/8, then you can't do that. You have to multiply everything by that denominator to get rid of that fraction. Let's just go ahead. I'm not even going to change it to 0.5. I'm going to multiply everything by 2. Take 2 times 3x, you get 6x. You take 2 times 17, you get 34. You take 2 times 1/2, you multiply 2 times the top, the 1, then divide by the bottom, which is 2. 2 times 1 is 2, divided by 2 is 1. So you end up with just plus 1x there, just plus x. 2 times negative 5 is negative 10. 2 times 180 is 360. Now we don't have any more fractions. We collect like terms. You got 7x equals, oops, not 7x equals, 7x, we got to collect these like terms, minus 44 equals 180. Add 44 to both sides, you end up with 7x equals 224. Divide by 7. Now to do stuff like this, you probably need to make sure you have your calculator. 7 will go into 22 3 times with 1 left over. 7 will go into 14 twice. So x equals 32. I'm just going to take that and I'm going to plug it back in. And I'm going to plug it in right here. 3 times 32 minus 17. 3 times 32 is 96. 96 minus 17. Have to borrow there, make that a 9, that's 8. 8, that's 79, so that angle is 79 degrees. To find the other angle, instead of plugging in over here with this fraction, which isn't too hard, sorry, I messed up back here. This shouldn't be 180 right here. I wrote it down wrong. That should be 360 because we multiplied it by 2. Well, all that's going to change all the way down through here. That's going to make this, it's going to change this right here. So we end up with 7x equals 404. Then you divide that by 7. Dumb, getting in a hurry. Divide that by 7. 7 will go into 45 times. That's 35. So 7 will go into 54. 7 times. All right, we're going to try 14 again because I messed it all up. So let's figure out what I did wrong here. We take this, again, we know they're supplementary, so that's 180. So 3x minus 17 plus 1/2 x minus 5 should equal 180. I'm going to multiply everything by 2. I'm going to be careful what I'm doing this time. That's 6x minus 34, 2 times the 1/2. Take 2 times the top, which is 2, divided by the bottom. 2 divided by 2 is just 1, so we end up with just 1x there. 2 times the negative 5 is negative 10, and then 2 times the 180 is 360. Collect like terms. You got 7x. Negative 34, negative 10 gives me negative 44. Equals 360. Add 44 to both sides. End up with 4, 0, carry the 1, 404, 7x. Alright, we're going to try 14 one more time because I figured out what I did wrong. I messed up and I wrote it down wrong from the book. This says 3x plus, or minus 17, in the book it says 3x plus 17. Again, these are supplementary, so they should add up to 180. So 3x plus 17, not minus 17, plus 1/2 x minus 5 equals 180. So I need to make sure I go back and fix that on my PowerPoint because I wrote it down wrong from the book. Make sure you don't make that mistake. Here I'm going to take this whole thing here, and I'm going to multiply everything by 2 just to get rid of that fraction right there. 2 times 3x is 6x. 2 times 17 is 34. 2 times 1/2, you take 2 times the top number, which is 1. 2 times 1 is 2. Then divide by the bottom number. 2 divided by 2 is 1. So you end up with 1x there. 2 times negative 5 is negative 10. 2 times 180 is 360. If you don't want to multiply all that by negative or by 2 to get rid of the fraction, don't use the fraction. It's just most people don't like fractions, so I get rid of it. Collect like terms. 7x, a positive 34 and a negative 10 gives us plus 24 equals 360. Subtract 24 on both sides. You end up, these cancel out. 7x equals 360 minus that, that'd be 6. Borrow from there, made that 5, that's 3. 336. Grab your calculator and take 336 and divide it by 7. You end up with x equals 48. Not everything has to come out all nice and even, but this one wasn't coming out the way I thought it should, so that's why I went back and checked over it. Now we're going to take that 48 and we're going to plug back into one of these. I'm going to plug back into this one with that fraction. 1/2 times 48 minus 5. When you're doing half times 48, all you're doing is taking half of 48. Well, half of 48 is 24. 24 minus 5 is 19. So one of the angles is 19 degrees. That's one of our answers. We know that they're supplementary. So all we got to do to find the other one, instead of plugging 48 back into here, because I don't know what 3 times 48 is, you just take that 19 and subtract it from 180. You end up with 161. So that's your other angle. So 161 degrees and 19 degrees. And it shouldn't have took that long if I wouldn't have messed it up right here. Next one, 19. Find the measure of each angle. 2 angles form a linear pair. The measure of one angle is twice the measure of the other. Anytime I'm doing a problem like this, this is one of the ones that people seem to have trouble with. What I want to do, I know I'm dealing with 2 angles, so I'm going to put angle 1 and angle 2. I don't know what angle 1 is, I don't know what angle 2 is, but we're just going to set it up this way. Anytime you see a problem that looks like this, 2 angles, and it gives you some big explanation, that's going to be that way for all of these down through here. I'm going to let one of the angles, usually I'm going to let one of the angles be a variable. Since we don't know it, I'm just going to let that one be x. So we say angle 1 is x. The measure of one of the angles is twice the measure of the other. Well, if one of the angles is x and the other one's twice that, then it's just 2 times x. We know that they're a linear pair, so that means they're supplementary. And if they're supplementary, that means that they add up to 180 degrees. So this angle plus this angle should equal 180. 3x equals 180. Divide by 3. You end up with x equals 60. Don't forget, that's not your answer. You want to find the measure of both the angles. That means this first angle is going to be 60 degrees. That's one of your answers. The other one's 2 times 60, which is 120. And you can always check yourself to see if they add up to 180 like they were supposed to on this problem. Next one, 2 angles form a linear pair. So again, these 2 angles add up to 180 degrees. The measure of one angle is half the measure of the other angle. So again, I'm going to do angle 1, angle 2. Every time, this is what you should do on a problem like this. Start out angle 1, angle 2. Angle 1, I'm just going to say it's x. The other angle is half of that one, so it's 1/2 times x. We know they're supplementary, so x plus 1/2 x should equal 180. Again, you can multiply everything here by 2 to get rid of the fraction if you don't like it. 2 times x is 2x. 2 times 1/2 is just 1, so you end up with 1x. 2 times 180 is 360. So now 2x and x, that gives us 3x equals 360. Divide by 3. 360 divided by 3 is 120. We come back over here and plug in. So this first angle right here is 120 degrees. That's one of our answers. The other angle is half that much. Well, half of 120 is 60 degrees. So the answer to this one and this one actually came out to be the same, but they wrote it different. Next one. Again, same thing. Angle 1, angle 2. It says the measure of an angle is 9 times the measure of its complement. Complement tells us that they got to add up to 90. We don't know angle 1, so we let it be x. The other angle, these two are complementary. The other angle is 9 times its complement. So if this one's x, the other one's going to be 9 times x. We add those together, x plus 9x should equal 90. You get 10x equals 90. Divide by 10. X equals 9. Once we know x is 9, we come back here and we plug in. So this angle is 9 degrees. This one is 9 times 9, which is 81 degrees. Those are our 2 angles. Next one, again, angle 1, angle 2. Angle 1, we don't know, so we're going to let it be x. Angle 2, it says the measure of an angle is 1/4 the measure of its complement. Again, complement tells us 90, so it's 1/4 of x. Pen won't write because I'm too close to the bottom. And we know those two are going to add up to 90. So x plus 1/4 x should equal 90. This time, to get rid of this fraction, I'm going to multiply the whole thing by 4. 4 times x is 4x. 4 times 1/4, you take times the top, then divide by the bottom. 4 times 1 is 4, divided by 4 is 1. So you get 1x there. And that equals 4 times 90 is 360. 5x equals 360. Divide both sides by 5. Grab your calculator and divide that out. You end up with x equals 72. Again, that's not our answer. We come back over here and we plug it in. So this first angle, 72 degrees. The second angle, instead of plugging in here, you could just say, okay, we know that they add up to 90. So all you got to do is take 90 minus 72, and that gives you 18 degrees. So one angle is 72 degrees, the other one is 18 degrees. They're complementary. They should add up to 90. Problem 23. Tell what the area is. Angle 2 and angle 4 are adjacent. Are angle 2 and angle 4 adjacent? No. They don't share a side. They don't share a side. Angle 2, we want to fix it. Well, to fix it, all you'd have to do is get rid of the angle 4 there. Angle 2 is actually adjacent to angle 3 or angle 1. You could put either one in there. We'll put angle 1 in there, and that would be fixing it. Next one, angle 1 and angle 3 form a linear pair. Angle 1 and angle 3, they don't form a linear pair. They're actually vertical angles. So we'd say something like angle 1 and angle 3 are vertical angles to explain it. They're not a linear pair. We wanted to fix it. Instead of angle 1 and angle 3, we get rid of angle 3. And angle 1 and what other angle form a linear pair? Well, angle 2. We could just stick angle 2 in there. Notice angle 4 doesn't form a linear pair with any of these angles because they don't have the same vertex. They don't share a side. They're not right there together. They're not neighbors. Number 25 says the measure of angle 1 is 58 degrees. The measure of angle 2 is 24 degrees when we're looking at this picture. So this angle right here is 58 degrees. Measure of angle 2, which is right down in here, that angle right there is 24 degrees. This is some bridge, I think, somewhere in Australia or somewhere, I can't remember. It says in your book, I believe. We want the supplement of angle 1. Well, find the supplement of it. Remember, supplement means 180, so all we do is take 180 minus 58. Borrow, end up with 2. That's a 7, 2. Okay, quit writing. So 122 degrees. Well, the reason we might want to know the supplement of that is because that angle right there is going to be supplementary to that. And we need to know what that angle is. Supplement of angle 2. This angle right here would be supplementary to angle 2. We might need to know that so we know what angle to put those wires at. So again, supplementary means 180, so we take 180 minus 24 this time. You end up with 156. Problem 28. Problem 28 says, the foul lines of a baseball field. Foul lines of a baseball field form a right angle. A batter hits a fair ball such that the path of the baseball forms a 27-degree angle with the third base foul line. What is the measure of the angle between the first base foul line and the path of the ball? So this right here, this angle is 27 degrees. They want to know what is that angle. Well, we know that those two angles together make a right angle, even though my picture doesn't really look like that's a right angle because it's took at a sort of a crazy angle. But that should be a right angle, and that means those two are complementary. So all we got to do is take 90 minus 27, borrow, it's 63 degrees. That should be your answer. (31). Measure of angle U is 2x. Measure of angle B is 4 times the measure of angle U. So that means 4 times the measure of angle U, which makes angle U and angle B a complement. So which one makes them add up to 180? I think I should say find x to, let's see here, let me read it out of the book. Which value of x? It should say which value of x. So we're trying to find which one of these would make them complementary or complements to each other, add up to 90. Well, if angle B, if the measure of angle B is 4 times the measure of angle U, and angle U is 2x, then we just take 4 times that 2x, and that means angle B's got to be 8x. Well, those two add together, 2x plus 8x. They're complements, so they have to add up to equal 90. That gives us 10x equals 90. Divide by 10, and you end up with x equals 9. That's the answer right there. They just wanted x in this case. They didn't want us to go back and plug in. 32 through 35. 32 through 35 says, in exercise 32, write it and solve an algebraic equation to find the measure of each angle based on the given description. Same idea here. I'm going to put angle 1, angle 2. I know that I'm dealing with two angles. The measure of an angle is 6 less than the measure of its complement. So all I'm going to do on this, I'm going to make one of the angles x. This other angle is 6 less than its complement. Alright, so that means it's got to be 6 less than our angle 1 there. And we know that the two of them together, since it's complement, it's going to add up to 90. So when I do this, you've got to be careful with less than. If I say 2 less than 5, that doesn't mean 2 minus 5. Less than means to subtract, but it means you got to switch these two around. So if it's 6 less than its complement, then it's not going to be 6 minus x. That's wrong. It's going to be x minus 6 is going to be this angle. Then we set up the equation. X plus the other angle, which is x minus 6, should equal 90. X and x give us 2x minus 6 equals 90. Add 6 to both sides. You end up with 2x equals 96. Divide by 2. Grab your calculator out. You end up with x equals 48. That's not our answer. On 32 through 35, they said, write and solve the equation, measure of each angle, give a description. Maybe that is our answer. They wanted us to find the angles too. So find the angles, we take that and plug back in. Well, this angle is going to be 48 degrees because it was just x. This angle is going to be 48 minus 6, which is 42 degrees. Next one, angle 1, angle 2, you're doing the same thing again. Complement, so it's 90 again. We're going to let the first angle be x. The measure of an angle is 12 more than twice the measure of the other angle. So this is the other angle. It's 12 more than twice. Well, 12 more than twice means we're going to add. We just got to translate this. 12 plus twice the other angle. The other angle is x. So I'm actually going to write it this way. 2x plus 12. We're going to add those two together. X plus the other angle, which is 2x plus 12. And that should equal 90. That's 3x plus 12 equals 90. Subtract 12 on both sides. Hopefully after you do some of these equations for a while, you can do some of this in your head. That gives you 78. Divide both sides by 3 and you end up with x equals whatever 78 divided by 3 is. 26. So x equals 26. I go back over here. This angle is going to be 26 degrees. That's one of them because it was just x. If I plug into this one, 2 times 26 is 52. 52 plus 12 is 64. And you could check your answer to make sure they're right by adding those together. They should add up to be 90. Next one, angle 1, angle 2. The measure one angle is 3 more than half the measure of the other angle. It's supplement, so that's 180 this time. On one of the angles, I'm going to let it be x, and then I'm just going to translate this. 3 more than half the other measure, so 3 plus half times the other measure. The other measure is just our x. So, and I'm going to turn that around, and I'm going to put 1/2 x plus 3. You could put 3 plus 1/2 x, it means the same thing. X plus 1/2 x plus 3. And this time they told us they were supplementary, so they should equal 180. I'm going to do the same thing here. I'm going to multiply this whole thing to get rid of this fraction. Multiply everything by 2. So you get 2x. 2 times 1/2 is just 1x. 2 times 3 is 6. 2 times 180 is 360. If you don't want to multiply everything by 2 and make that extra step, then don't do it. Figure it out using the fractions. 3x plus 6 equals 360. Subtract 6 on both sides. You end up with 3x equals 354. Take 354 and divide it by 3. And you get 118. So x equals 118. Again, that's not our answer. We take it and we're going to plug it back in up here. The first angle then is going to be 118 degrees. Easiest way to find the second angle, we know they're supplementary, so take 180 minus 118, which gives you 62 degrees. Those are your two answers. Next one, angle 1, angle 2. Angle 1, we're going to let be x again. This time they tell us they form a linear pair, so again that tells us they add up to 180 degrees. Measure of one angle is 15 less than 2/3 the measure of the other. 15 less than, so that means subtract 2/3 the other, so it's going to be 2/3 x, but we got to switch these two around because it says less than. So the other angle is going to be 2/3 x minus 15. We set up our equation, x plus 2/3 x minus 15 should equal 180, because they told us they were a linear pair. I'm going to multiply this all by, this is one where it's probably a good thing to get rid of the fractions. Multiply everything by 3. 3 times x is 3x. 3 times 2/3, you take 3 times the top number, so 3 times 2 is 6, then you divide by the bottom number. 6 divided by 3 is 2. 3 times 15 is negative 45. And 3 times 180 is 540. Collect like terms, we get 5x minus 45 equals 540. Add 45 to both sides. You end up with 5x equals 585. Grab your calculator and take 585 divided by 5. You end up with x equals 117. We go back over here. This angle then is 117 degrees. Another one, I really don't want to plug in there 117 and figure out what 2/3 times 117 is. So since I know that they add up to 180, I just take 180 minus 117 and I get 63 degrees. (36 through 41), always, sometimes, and never. Complementary angles are adjacent. Do two angles, if they add up to 90, have to be adjacent angles? Well, if I draw these two angles, I tell you that angle's 30 degrees. And then I draw this angle, and I tell you it's 60 degrees. They add up to 90, but they're not adjacent. So this one is sometimes. Angles in a linear pair are supplementary to each other. If two angles form a linear pair, so if I draw this, no matter how I draw it, and I draw another ray in here, and I got angle 1 and angle 2, together they form a line. They're always going to be supplementary. If it says it the other way around, if it says two angles are supplements, then they form a linear pair. That doesn't have to be the case. So linear pairs are always supplementary angles, but supplementary angles aren't always linear pairs. Vertical angles are adjacent. Sorry, I didn't type that right there. So you got two vertical angles. If I draw my picture here, angle 3 and angle 4 are vertical angles there. Are they ever adjacent to each other? Never. Vertical angles can't be adjacent. Part of the definition says vertical angles are non-adjacent angles. If an angle is acute, so less than 90 or between 0 and 90, then its complement is greater than its supplement. That's going to be never. If you have an acute angle, its complement is also going to be an acute angle. If you have an acute angle, its supplement is always going to be an obtuse angle. If two angles are complementary, two angles are complementary angles. If two complementary angles are congruent to each other, then the measure is 45 degrees. Well, if they're complementary, that means they add up to 90. If they're congruent, that means they're equal. The only two angles that add up to 90 and are equal to each other are both 45 degrees. So this is always. The two supplementary angles that are congruent to each other would have to be 90 degrees. Explain why the supplement of an acute angle must be obtuse. The biggest acute angle we can get is like 90 or I'm sorry, 89.9999, we'll just use 89. Well, if I subtract that from 180 every time, I'm going to get an angle that's 91 or bigger. And that's always going to be an obtuse angle. And the reason is to add up to 180, if you have an acute angle, to add up to 180, the other angle has to be more than 90. Explain why an obtuse angle does not have a complement. Well, if it's an obtuse angle, that means it's more than 90, so something like 91 is an example. Well, the complement of 91, complement means they have to add up to 90. Well, what plus 91 equals 90? Well, the only thing that plus 91 equals 90 is negative 1. So that angle would have to be negative 1 there, and we don't have a negative angle. We're not dealing with negative angles. So the reason is it doesn't have a complement is because an obtuse angle is already more than 90. Can't add up to 90 with something else if it's already more than 90. 45, they want you to find the measure of UWB. UWB. So I look at this, and whenever I'm doing a problem like this where it has a whole bunch of angles on it, I'm going to go over here to the picture, and I'm just going to find every angle that I can possibly find. And then I'm going to worry about answering the questions. So if I look at this right here, I look at these two angles, I know that together they form a line. So they have to be supplementary. Well, if this is 30, then this angle has to be 50. So I write that in there. I look at these two angles, and together they form this right angle. Well, that means they got to be complementary. They got to add up to 90. So if this is 50, this angle has to be 40. Then I look at these two angles, and I say, hey, they form that line right there. Well, if this is 40, this angle has to be 140. Now let's go back over here. Measure of angle UWB. UWB, we figured it out, it's 50 degrees. Anytime you have a bunch of angles in a picture like that, figure out all the angles, then come back and answer the questions. Angle TWU, we already figured out, is 40 degrees. Angle TWX, that's this angle, we figured out is 140 degrees. Anytime you have a picture that has a whole bunch of angles in it, it could have even more angles in here. Go through and figure out every angle that you can possibly figure out, then worry about answering the questions. Makes it easier. Next, 46, true or false, based on the given information. This is what this is telling you about is the fact that you can't just assume things. This should say segment CF, I don't know how, or segment CA and segment AF. I didn't put none of my symbols on top of these. Let's make sure that I'm right here before I say all that. Make sure that's what the book wanted. Those are segments, and then these others here, these are segments, and these three here are lines. I have no clue why I didn't put my symbols in there. That's a line, that's a line. Segment CF is congruent to segment AF. True or false? We look over here, or segment CA, not segment CF. Segment CA is here to there. Segment AF is here to there. They have the tick marks on them. That tells us that they're congruent, so that's true. We can tell that. Points C, A, and F are collinear. Collinear again means they're on the same line. C, A, and F. Are they on the same line? Yes, that's true. We can tell that from the picture. Angle CAD. CAD is that angle, is congruent to angle EAF. EAF, which is that angle. They almost look like they're vertical angles, but they're not because these two sides aren't opposite of each other. So that we can't tell. That's false. You can't just say that not knowing any more information than we know. Line CF, line BE, and line AD intersect at point A. Line CF, line BE, and line AD Well, a lot of you probably look at this and say, well, AD is not a line. Well, if we wanted it to, could it go on out that way? Yeah. And do they all intersect at point A? Yes, that's true. Angle BAC and angle CAD are complementary. Complementary again means they add up to 90. So angle BAC, that's this angle right here. And angle CAD, which is this angle. Do those two angles add up to 90? Yeah, because they put that box right there in there for us. So that one is true also. Angle DAE is a right angle. Angle DAE is a right angle. Well, they didn't put that box in there for us, but we know that this angle over here is 90 degrees. And we know that these two angles, this whole thing and this angle over here, together have to form this straight angle. So if this one over here is 90, to find the other one, all we got to do is take 180 minus 90, and that gives us 90. So what do we know about this angle? It's got to be a right angle, so that's true. 47, angle KJL is complementary to angle LJM, and angle MJN is complementary to angle KJL. Well, notice here, you got KJL there, you got KJL there. So this one and this one add up to 90. This one and this one add up to 90. If I tell you that angle LJM is X, I'll put that on there right. LJM. Let's see, angle KJL and angle LJM are complementary. Angle MJN and LJ, I wrote this one wrong. This should say angle LJM. Should say angle LJM. So they're saying that they're both complementary to that angle. So this angle and this angle add up to 90. So this angle right here could be just 90 minus X. We don't know what X is, but it could be 90 minus X because we know that these two have to add up to 90. Well, these two have to add up to 90. Well, then this one could also be 90 minus X. Well, we look at these two. What's that tell you about those two? Yes, they have to be congruent. If they're both complementary to this same angle, LJM, if they're both complementary to that angle, then they have to be the same. So in other words, if we made up a number, let's say we made up a number for this angle and said it was 30 degrees, and we knew that these two were complementary, well then this angle's got to be 60 degrees. If we know these two are complementary, then this angle has to be 60 degrees, and no matter what numbers we pick, these two are always going to end up being the same thing. 48. 48 says, and again my typing's not very good here apparently, light from a flashlight strikes a mirror and is reflected so that the angle of reflection is congruent to the angle incidence. If you look down there, it shows you the angle of reflection. Angle incidence is before the light hits the mirror. Angle reflection is after it hits the mirror. Your classmate claims that angle QPR is congruent to angle TPU. Angle QPR is congruent to angle TPU. These two angles are congruent. Is that always going to be the case? Yes. If you take a flashlight and you shine it right here, and it hits that mirror and it reflects off, the angle that it hit the mirror at is always going to be the same as the angle it reflects off at. It's just like on a pool table. If you ever play pool, you got your pockets on the pool table. You got the cue ball set in here and you hit that cue ball down this way and it hits this rail at a certain angle, it's going to bounce off. These two angles right here are going to be the same every single time. (49) Write an expression for each angle. So all we're going to do is write an expression for each angle. Well, if this angle right here is y, the one vertical to it has to be exactly the same as it, so it's just going to be y. These two angles are supplementary because they're a linear pair, they form a line. So if this angle is y, this angle is going to be 180 minus y. Well, what do we know about these two angles? They're vertical to each other, so this angle's got to be 180 minus y. We can't really do anything with that for right now. We can't figure out what y is, but we can set up an expression for each one. 52 through 59, always, sometimes, and never. On this, you've got to remember all your little things. If you're dealing with with integers, whole numbers, irrational numbers, rational numbers, all those different kinds of numbers. You might want to copy this down at some point if you don't remember all this. This is what your sort of a Venn diagram of all your numbers. All right, everything is in the set of complex numbers, the original numbers, natural numbers, or counting numbers that you started with. Go like 1, 2, 3, 4, 5, 6, 7, 8. Then whole numbers added on 0. So natural numbers, if it's a natural number, it's always a whole number because it's inside the natural numbers are all inside this box. If it's a whole number, it's not always a natural number because 0 is a whole number, but it doesn't fall inside the natural number box. Then you dealt with integers. Integers included the negative numbers. No fractions or decimals yet, just the negative numbers. Then you went to rational numbers. Rational numbers included fractions, decimals, all that stuff. Notice that all natural numbers are rational numbers, but not all rational numbers are natural numbers. -5 isn't a natural number because it doesn't fall inside this little box. It falls inside this bigger box here. Then after rational numbers, you have irrational numbers. It's sort of its own set over here. Those two sets together, rational and irrational numbers, are all the numbers that you've ever seen so far in your mathematical career, which are real numbers. And then at some point, you might also be introduced to imaginary numbers. Imaginary numbers, along with real numbers, form our whole number system, which is complex numbers. So we're going to use this to answer those questions. An integer is a whole number. Is that always, sometimes, or never? Are all integers whole numbers? That's going to be sometimes. An irrational number is a real number. If we look back at this, we want rational number. Is it always a real number? So we look at a rational number. A rational number, something in here. Is it always a real number? Are all rational numbers inside this box? And that's yes. So that's always. And I'm going through these wrong. I should have did 53. Let's go over here and do. An integer is an irrational number. Can an integer be an irrational number? Let's go to this next thing. An integer is in here in this box. Is that ever going to, is any number in this box ever going to be over here in this? And that's no. So that's never. Next one, let's do 55 since I went in the wrong order. A whole number is negative. Go back to this. If we have a whole number that's in here, is there any negative numbers in there? No. Whole numbers can never be negative. You got to get out to integers before you start dealing with the negatives. So this is never. Next one, a rational number is an integer. Can a rational number be an integer? Well, integers fall inside the rational numbers, so that's sometimes. Sometimes it'll be an integer, sometimes it won't. A whole number is a rational number. That's always. All whole numbers fall inside the box that's a rational number. And again, I went the wrong order. A natural number is an integer. So we look over here. We look at our natural numbers. That's in this little box. Can that natural number be an integer? Yeah, all natural numbers fall inside the box that's integers. So that's always. If it was turned around, can an integer be a natural number? That would have to be sometimes, because some integers are natural numbers, some are not. An irrational number is negative. Can an irrational number be negative? Yeah. Does it have to be negative? No. So that's sometimes. Again, you might want to copy that box down.